So welcome everyone. So I have to maybe announce at the very beginning. So I think my talk will kind of be different from other highlight talk in that I won't go into super deep detail about like the technical aspects of GPT-3. It will be more about like my personal or a practitioner's misadventures with the GPT-3 API that is provided at the moment as a beta version by OpenAI. So what is GPT-3 is maybe a question. So the cynical answer is basically it's GPT-2, but bigger. And I think that's actually not quite that unfair framing, because like if you read the paper, they basically say it's basically the same architecture. It's just like everything scaled up to the max. So maybe some key data points on this. So, I mean, it's a transformer-based autoregressive language model. So I think the autoregressive part here is kind of important because unlike other transformer-based models like BERT, it doesn't do masked language modeling, but it actually kind of predicts the next token based on all the previous tokens, kind of like you know from your standard language models. And kind of why it stands out is basically the next 2 points here. Like one of it is it's gigantic, so it has 175 billion parameters, which I think at the time they claimed it's kind of 10 times bigger than anything that came before it. And the other point is that it's been trained of just on like a gigantic amount of text. And I think, so here, so my personal philosophy with like NLP model training is usually it's way more important to talk about data than it's to talk about models. And so I want to highlight here maybe a few key points like of their training data. So you can see that the large majority of data comes from a common crawl, which is basically just a data set of like of web pages. But you see here, like importantly, that they actually kind of do quite a bit of pre-processing on the common crawl corpus, and they augment it with selected more specialized corpora like books and Wikipedia. So kind of the main selling point of GPT-3 is, first, it's really scarily good at text completion, which is probably like what you all previously heard about, like it's all over the news all the time. And maybe the more important or more interesting part for us as practitioners is actually it can kind of solve a lot of NLP tasks with only few examples given, and on top of that without actually updating the model parameters. And in this talk, I will kind of give you, or I will kind of show you how these 2 points are actually connected. They're basically the same point, which is really cool. Like it's really impressive. So yeah, so the second point is basically why the paper is called Language Models Are Few-Shot Learners. So the few-shot part is here, like, okay, you need only like 32 examples. So let's quickly kind of bring everyone up to speed on like how text completion works, basically. So you have kind of 2 components. First, you provide the model with a prompt that is kind of arbitrary text. So you could put, for example, say, okay, yesterday I went to and then you have a completion part where the model will predict maybe beach or store or apple. And of course, like not all of these completions are the same quality, but like if you have a good language model, it will probably pick beach, I would assume. So how can you kind of very intuitively use this? I mean, no talk about GPT-3 is kind of complete without misusing it as a chatbot. So here I have a very short conversation. So I say, hey there, GPT-3. GPT-3 says hi back. I say, how do you feel about Swiss Text 2021 so far? And it says, well, I like it. I find it interesting that it's more complex than the previous version. I mean, I guess that's quite a compliment. And so how does this relate to this text completion idea? So here it's very simple. So I have a first prompt, which is basically everything you see in bold in this red box. And then the completion is just what the model gives here in green. And then you can basically take the same text, extend it with your own new input, and then feed it back and get like a new completion. And that is very simply how you could do a chatbot with GPT-3. Or basically any language model. One of the best applications you'll probably find out there, or one of the more convincing ones, is this AI dungeon. So I really want to highlight this. It's really cool. So basically you go there, you can like, they made a really nice little interface around it where you can kind of select a character and what kind of genre you want to be. And then you can kind of play old school text adventure style games with it. So you're kind of it tells a story about like you are a princess and the kingdom is attacked, and then you are informed of this, and then you can kind of interact with characters in the world. It's really cool. Of course, obviously there's quite a bit of potential for misuse of stuff like that. So I mean, we have kind of talk about this aspect also, because that's kind of the other point that was pointed out quite a lot in the media, is like the potential to abuse it for like fake news generation. And kind of the relevant table from the paper here is, you can see here where they kind of did a small human study where they kind of generated a bunch of short news articles and then asked humans whether it was kind of authentic or bot generated. And you can kind of see here that like the large 175 billion parameter model, like in like humans were only like 50%, 52% accurate in predicting whether a given snippet of text was like human or bot generated, which is quite impressive. And then it's kind of like, yeah, it's kind of the source of a lot of the controversy or like a lot of news reporting. So this kind of leads me into kind of a first little anecdote about my own experience with something similar. So I call this story Bobby's Banana. So basically, like there's the idea was inspired by one of my co-workers, and he was like very interested whether you can kind of build a chatbot that will lie to you. So here you have a small story about like Bobby, who has like taken the last banana out of the fruit bowl, and even though his mom kind of wanted to make fruit salad or something, and now he feels bad about it. And the idea is to make the bot lie. And so here you can kind of see how this looks in the OpenAI kind of web interface. The text is probably too small for you to read. I don't think that's very, the text itself is not very pertinent. So like if you click complete here, it will actually kind of give you a story, but and it will actually also kind of then hallucinate something about like how lying is not worth it and blah, blah, blah. So like it's moral pontification, which is quite interesting. But the very first time I tried this out, actually, I got this screen. So, I mean, OpenAI is kind of quite aware of of potential abuse of older models. I mean, maybe you remember back when they released GPT-2, at first they said like, yeah, we are not going to release this model because it's so dangerous and stuff. And in the GPT-3 paper, they actually spend a lot of space on talking about potential problems or potential abuse of large language models. So not only like the fake news stuff, but obviously also like gender bias and all these associated problems. And here, I mean, especially for the beta access, they actually are quite restrictive what you can or what you should do with it. So they have here this content filter where they kind of try to detect all kinds of unsafe behavior. So for example, a chatbot that is kind of lying to you could be considered unsafe, and they tell you like, okay, please do not share this with the public, etc., etc. And this kind of also ties into their terms of service. So imagine you have whatever application you built with the OpenAI thing, you actually have to go through a pretty rigorous app review process. So they actually are quite strict what they like what they mean when they say, okay, once you take the app productive. So even if you do only kind of an internal demo at your company, as soon as like 5 to 10 people interact with your application on a regular basis, they consider it to be in production, and then you have to go through their review process. And so there's obviously a couple of things you will fail the process if it has anything to do with just like bot spamming social media. Like there's just no way that's ever going to be accepted. Almost nothing that is like very kind of intrinsically dangerous domains, they will not allow you to, or I mean, it's obviously on a case-by-case basis, but in general, they won't like have a bot give medical advice or like, I don't know, investment advice or anything of the sort. And they're very clear that they do not want kind of end users to be able to just get unfiltered access to just raw model outputs. So like if you do anything text generation based with kind of more than that, kind of generates more than 2 sentences at the time, this is kind of the rough guideline they give you. And yeah, so I mean, that's just something to be aware, and I think that's actually quite reasonable. Okay, so now like, okay, we talked about a little bit about how text completion works in general. So kind of let's see whether we can actually do something productive with that. So like, can we actually solve any NLP task with this? And the answer is kind of yes. So the core idea what you want to do is you have to write a prompt such that the completion to your prompt is kind of the solution to whatever problem you have. So here I say kind of write a prompt in such a way that the best completion is the solution to your task. And so like here's really that concept of prompt engineering that's quite important. So for a very concrete example, I prepared here a little prompt. So here you can see kind of the full-blown web interface that they provide. They call this the playground. So you have like this large text window where you can enter your prompt. On the right side, you see a couple of the knobs you can turn to kind of influence how generation works. We'll not go into too much detail about those. So here in the middle, so you can see a prompt. So what I want to achieve with this prompt is basically, it's similar to one of the shared tasks that was running on Monday, where it was about correct punctuation. So what I did here, first I tell it, okay, look, this is about proper punctuation. So I tell it correct a given paragraph by adding proper punctuation capitalizing when necessary. I then give it an example, input and output. So I tell it, okay, for this given input, where I just took some paragraph from Eurolex, I think, so European parliamentary proceedings or whatever, I stripped all the punctuation. Then I said, okay, for that given input, I want an output that looks like, well, the same paragraph, but with all the punctuation inserted. Next, I give it another input. This is the one that I want to actually be, this is the one I want to be corrected actually. So this is just another sentence or two from your lex with all the punctuation stripped. And then if I press submit, which will trigger the completion of the prompt, it actually kind of copies my input sentence and correctly inserts all punctuation. And I intentionally kind of took a bit of a complicated example. So here is quite a complex enumeration, and it kind of perfectly completes all the punctuation. Maybe, I mean, this task might be too easy for it. So here you can see also some artifacts. So it actually goes on to generate more than just the completion I wanted. It actually hallucinates a new input example, and then in the output, it starts kind of correcting its own like miss or like the own example it gave itself, which is kind of interesting. The reason why it over-generates is just basically I set the response length to a fixed length. So I just tell it, okay, give me 128 tokens of response, and I don't tell it to kind of stop generating after, like here, for example, you could tell it to stop generating after it encounters line break. So kind of to distill it down, so how does this prompt engineering actually work? So the ingredients you need is kind of, you tell it what the task is about, which is kind of interesting. So you give it kind of a natural language description of your task, and after that, it's already primed to solve your task, which is actually super amazing. You provide it with one or more the quality examples. So I mean, obviously, as with almost any model, the better your examples are, the better it will be at handling your task. And the third point that's equally as important is actually to kind of, your prompt should be structured in a way that it is very easy to predict how the model completion should actually look like, how the answer to whatever you want should look like. So as another example, here how you would do that for a classification task. So this is actually an example pulled straight from their documentation. So here you can see basically you have the task description at the top. So here it's very simple. It just says this is tweet sentiment classifier. You have these bunch of examples with just where you have a tweet text and the sentiment. And you have this very structured prompt with like where every single example is kind of separated by these 3 hashtags, which makes it very easy to predict how actually the continuation should look like. And then in the end here, kind of this is the money part where you can actually just kind of replace whatever tweet you want classified. So you could replace this new video blew my mind with whatever tweet you want to be classified, and it will then kind of provide you with a positive, negative, or neutral label. And this is kind of what we talk about when we say it's doing few-shot classification, because in the sense here, what it does is based on 4 examples, it will kind of predict sentiment annotations, which is quite impressive. They actually also provide you with an alternative API for certain tasks. So for classification, question answering, and search, which are quite common tasks. So they kind of provide you with prefab prompts, or like you can get around prompt engineering by using those API endpoints. And we'll see that kind of in a minute or two. They're a bit tricky to use. So what those API endpoints actually do is you provide them with like a large collection of reference documents. So for example, for a search endpoint, this would be like all the documents you want to be able to query over. And then what it will do, given a query, it will first kind of, based on kind of traditional methods, select a specified number of the reference documents that might be most relevant. And then it will kind of use GPT to rank those documents by relevance. Depending on what you're asking it, it might actually automatically create a prompt based on the task and your documents. and then extract the answer from the prompt completion. And yeah, so here you can imagine there's quite a few knobs to turn. So first of all, you have to kind of know how many documents it makes sense to search over. You can actually specify two different types of models for your search, for like the score, the ranking part, and the completion part. So so the question now is obviously like, do I have some experiments for you? I actually planned quite a few here, but I ran into some issues, which first of all turns out like if you want to actually do like rigorous experimentation with these models, it gets quite expensive quite fast. So here you can see kind of how their pricing model works. So when we talk here GPT-3, they actually provide you with 4 different kinds of models. So they are called Ada, Babbage, Curie, and Da Vinci. The kind of from most expensive and most accurate to least expensive, least accurate, but also fastest. And I wanted to show you kind of a a hate speech detection problem with like a couple thousand training examples and a few hundred test samples. But I basically blew through my whole budget in like 10 minutes. And because at first I used like the less performant models, Curie and Ada, and the results, like, they're not worth showing, they're so bad. And like the Da Vinci results looked way more promising, but they were so expensive that I couldn't get it up to a sample size that it was like worth anything. So I have to disappoint you here. I do not have kind of strict performance analysis for hate speech, but I can tell you that it's probably worth it to use Da Vinci if you have kind of your trial credits still available, or money to blow. Because I think I literally blew through my $120 limit within like 20 minutes or so. So thank you very much for your attention. I hope there's enough time to answer your questions.
Thank you very much, Pius. Thank you for this presentation. We have time to ask questions. So maybe the first question, there is Larissa has asked the question on the discussion chat. She said, on which page did you get the content warning?
On which page did I get the content warning?
Yes.
So it's basically when you click submit in the web form. Maybe I can go back there.
Yes, please, to the slide where you show the content warning.
The first time I tried something like that, I think it wasn't exactly the same Bobby with the banana story, but it was something very similar. And here, when I clicked submit, the content warning basically popped up immediately. So like even before it shows me the completion, the finished completion, it already tells me, hey, there's something unsafe with the output you're about to see. Please do not share it with anyone. I hope that answers the question.
I think yes. Thank you. Yes, so thank you for this answer. So we can go to the next question.
So may I ask a question? Pius, is it possible to reuse a prompt? I mean, assuming you want to do a hate speech classification and you have a training set of 20 samples, and then you want to classify one text. And if you have to repost always the same prompt, that will cost you a lot of money, which is a good business model, but it will also cost a lot of computation power and stuff like that. So could you basically store a prompt and reuse it later on or something like that?
That is an excellent question. So if you use it naively like I did, no. I'm not aware of a way to do that. But I also have to admit, I did not go maybe deep enough into the API because, I mean, obviously it would make sense to just store the prompt, like store the tensors or whatever, but not that I'm aware of.
Okay.
Okay, thank you. Another question maybe? Pius, did you try other tasks with this GPT-3 that you have already tried with GPT-2? And did you notice any difference?
We did try for some semantic similarity scoring. So we are working kind of on another idea where we kind of want to look at the semantic similarity between some generated text and some human texts. And there we use the search API to kind of get like a semantic similarity score. And there again, I didn't use the Da Vinci model for pricing reasons, but like with the faster, like less powerful models, you got kind of comparable results to just some kind of Roberta NLI model or something similar.
Okay. Yeah, maybe another question. All the examples that have been tried are generally examples. If we try really examples for in restricted domains, for instance, in a domain of engineering or a medical domain and so forth, how do you expect the results there?
I mean, it's a bit difficult because like it won't always kind of conform to like your expectations, in the sense that like even if you engineer a prompt really well and you give it all the kind of the data points it needs, like for example, I don't know, like you give it some structured input and you expect kind of a text that reflects those facts or something. I mean, it will try its best. It's really good, but like, I don't think there's a guarantee it will actually always conform. So there's kind of a risk associated with that.
Mm-hmm.
I see that there's one person raising their hand.
Yes, please. Yes, Matthias.
Yeah, thanks for the very nice talk.
Thank you.
I recently stumbled across a paper from some NYU guys who questioned whether it was really true few-shot learning, as they call it, since there had to be some prior training data to be involved for the selection of different prompts. Because they say different prompts heavily influence how well the model generalizes and so on. Did you also experiment with different types of prompts?
So usually it takes me 2 or 3 tries to kind of get consistent results. So usually like the very first prompt that comes to your mind for some specific task probably won't do.
Okay.
So it is actually real prompt engineering, or I mean, it's more like magic in a sense.
Yeah. Okay, cool, thanks.
Okay, Matthias. Question from Niklas Linus.
Yes, thank you very much for your introduction, Pius. I have a question also regarding the prompts. Have you experimented, or are you aware of any experiments that test out tasks that aren't directly related to language, such as calculations or logical inferences with syllogisms?
So I think I'm not sure whether it's in the archive version or in the NeurIPS version of the original publication, they do have experiments on, I think, arithmetic, so just addition and stuff. I'm not 100%, like I could not kind of give you details right now. I don't recollect at the moment, but like you can ping me and I will send you link to the paper with the relevant section.
So maybe I can add something here, because I just tested a couple of days ago this GPT-J model, which is open source and available also, and you can prompt it with some nice small arithmetic task like addition of 5 and 7, or what is 0.5 minus 27, and it works decently well. And this GPT-J model is equivalent to, I think, the second smallest model which you had in your table. So comparing to the large scale model, I would assume that it can calculate pretty well already. So it can do multiplications and stuff like that, at least for small numbers.
Yes.
Thanks.
Okay, thank you. I can see that Daniele raised his hand. Daniele?
Yeah, I wrote down my question in the chat. I was wondering if you experimented with GPT Neo. Based on the data that they show, it compares favorably with Ada, but Ada is pretty far from Da Vinci. So I'm wondering what your experience was with GPT Neo.
Honestly, I haven't tried any of the community efforts to reproduce this. I've only played with the OpenAI version so far.
Okay, thank you.
But I mean, there is a remarkable difference between Ada and Da Vinci. So like, if you want to really get your mind blown, you need to use the Da Vinci model.
Yeah, that's what I was kind of wondering, because Ada's so far from Da Vinci that I don't really see the point of, if you want to get the full power of GPT-3, you can't really use GPT Neo. That was my impression.
Yeah, I think so. If they claim to be about that Ada level, definitely it's not good enough.
Thank you.
You're welcome.
Thank you, Daniele. Is there a further question?
No, I'm good. Thank you.
Thank you. I think we are done. Thank you very much, Pius, for your presentation. It was impressive.